Hey everybody, here's a brief video introducing verifying trig identities, also known as proving trig identities, which I know you're all excited about because you love proofs. So if we have an identity is any equation that is true for every value, for every input value over the domain of the equation. So that's something, and we have some of them. Sine squared of x plus cosine squared of x equals 1 is an identity. Regardless what you put into x, any value that satisfies the sine function, the cosine function, if you square them, it's going to equal 1 every single time. So that's what an identity is. And we're going to be working on proving that equations are identities. I'm not going to give you any that aren't identities. We're only going to be verifying identities. If it's not an identity, that's because I made a mistake. And you guys will not be penalized for that because that is entirely on me. The main key when verifying an identity is that we're only going to work with one side of the equation. So what we're going to do is we're going to do basically what we've been doing with simplifying trig expressions, except we're going to do that to one side of an equation to make it look exactly like the other side of the equation. So we're not necessarily getting into simplest terms, we're getting it to look like that other side. So there's a few strategies. The first strategy is very much like the first strategy for simplifying. Just write everything as sines and cosines. So let's say we have the equation cotangent of x plus 1 equals cosecant of x times cosine of x plus sine of x. I should have started that a little bit more towards the left, whatever. So what we're going to do is we're only going to work with one side of the equation. And that means the other side's not changing. Now, if we're trying to simplify down one side of the equation, more often than not, it is easier to simplify down the more complicated side, the one with more stuff, than it is to build up the other side. This one's not bad. It's literally our first one, so we could work with either side, but I'm going to work with the more complicated side, which means that this cotangent of x plus 1 is not changing. But I also don't feel like writing cotangent of x plus 1 every single time. So what I'm going to do is I'm going to do an abbreviation of LHS for left-hand side. So I can write LHS anytime I want cotangent of x plus 1, so I can carry this down throughout this left-hand side of the equation. Now, if we want to maintain this right-hand side, that's right, we would use RHS. Very good. I'm impressed that you guys picked up on that so quickly. So now we want to write everything in terms of sines and cosines. Well, the only thing to change is that cosecant of x. That's 1 over sine of x, and then cosine of x plus sine of x. Now, if you recall in geometry when we did proofs, we couldn't really skip steps. Same thing here. We're not going to be able to really skip steps. So we're going to have to show the algebra out. LHS equals cosine of x over sine of x. We have to show the arithmetic out before we can replace it with our known identities. Because we know that cosine of x over sine of x is cotangent of x. But one thing we can do is 1 over sine of x times sine of x is 1. Anytime a reciprocal times the value is being multiplied, it's always going to give you 1. So you don't need to show sine of x over sine of x. You can jump straight to 1. But now, that's cotangent of x plus 1. And that's what we wanted. And in your verifying, your last step should always be exactly the same thing on the left-hand side as you have on the right-hand side. So this should always match up. So we only worked with one side of the equation, essentially ignored the other side in order to get them to match up. So that's our first strategy. Our second strategy is rewriting a fraction as a sum and difference of two fractions. So let's say we had tangent of x minus cotangent of x divided by sine of x cosine of x equals secant squared of x minus cosecant squared of x. All right. So we're trying to break down the more complicated side to look like the more simplified side. Well, there's a lot more going on that left side. So we're going to try and get this left side to look like this right-hand side. And we've got a fraction here. We don't have a fraction over there. We have a difference, though. We have a difference inside the fraction. So we can separate that fraction and produce the difference that we want. Tangent of x divided by sine of x cosine of x minus cotangent of x divided by sine of x cosine of x equals the right-hand side. I don't feel like writing secant squared of x minus cosecant squared of x over and over again. You could, no one's stopping you, but 3 letters is a lot faster. And now we've got our difference that we want. And, well, maybe if we make this all sines and cosines, it'll help us out. So tangent is sine of x over cosine of x divided by sine of x times cosine of x. And cotangent is cosine of x over sine of x divided by sine of x cosine of x. And then we can do the arithmetic to simplify this. The sines would divide off. These cosines would divide off, leaving us with 1 over cosine divided by cosine. That's 1 over cosine squared of x. And 1 over sine divided by sine, that's 1 over sine squared of x. And that equals our right-hand side. So lastly, hey, 1 over cosine squared is secant squared of x. 1 over sine squared is cosecant squared of x. Hey, that's what we wanted. Secant squared of x minus cosecant squared of x. So that's another strategy. A third strategy is sometimes you'll have an expression like this. Cosine of x divided by 1 minus sine of x equals 1 plus sine of x over cosine of x. So we have all sines and cosines, and we want all sines and cosines. And really the only identity that relates sines and cosines is our Pythagorean identity. Sine squared plus cosine squared equals 1, or the manipulations of it where cosine squared equals 1 minus sine squared and sine squared equals 1 minus cosine squared. So if you have a situation like this, oftentimes you're going to want to use the conjugates to produce that difference of squares. Either the cosine squared equals 1 minus sine squared or the sine squared equals 1 minus cosine squared. In this case, we already have the 1 minus sine of x or the 1 plus sine of x. Neither side is more complicated, so it doesn't matter which one you work with. I'm just going to work with the left side for kicks and giggles. So if we multiply top and bottom by the conjugate of the denominator, you get cosine of x times 1 plus sine of x. If you're multiplying by the conjugate, if it's not producing the difference of squares like it wouldn't in the numerator, don't multiply through. I strongly recommend multiplying through as a last resort. Oftentimes something's going to divide off nicely. And then 1 minus sine squared of x is the result, and that equals the right-hand side. Oh, we know what 1 minus sine squared of x is. That's cosine squared of x. Oh, you got a cosine in the numerator and 2 cosines in the denominator. So one of them divides off, leaving us just the 1 plus sine of x in the numerator and the cosine of x in the denominator, which looks pretty familiar because that's what we wanted. All right, so if you recognize that you can create the difference of squares using a conjugate, do it. And the last method. Let's say we had two fractions, 1 over 1 minus sine of x plus 1 over 1 plus sine of x. And they're trying to equal one term. Well, obviously the left side's more complicated than the right side, so we're going to want to work with the left side. But we don't want a sum, we want just one term. So if we have two fractions added together and we want to make them 1, you need a common denominator. And the common denominator would be gotten by multiplying those two denominators together, which is 1 minus sine squared of x. So this one was missing 1 plus sine of x. This one was missing 1 minus sine of x. And then when we simplify, 1 plus 1 is 2. Sine of x minus sine of x is 0. And 1 minus sine squared is cosine squared of x. And 2 over cosine squared, well, 1 over cosine squared is secant squared. So 2 over cosine squared is 2 secant squared. So that's verifying trig identities. You will have some practice to do now, but have fun.